Okay, hello physical science, this is Mr. B, and we are going to start chapter 2 with this video, and the title of this chapter is Properties of Matter, and this chapter will also introduce us to our bigger unit that we're going to have. It's going to actually start our chemistry unit. So if you remember from chapter 1, we talked about how there's two main branches of physical science that we are going to focus on, the first one being chemistry, and the second one being physics. So this is now where we're diving into the chemistry aspect of this class. And the title of our first section, which we have it broken up into two parts here, is called Classifying Matter. Now, we mentioned matter early on when we talked about the big ideas within physical science, talking about how matter exists in there. And however, they didn't really give us a definition of matter, so I looked one up on the internet. And matter, basically, to put it simply, almost maybe a little bit too simply, is anything that occupies space. So we are going to focus on the properties of any single object that occupies space within our world. So that's what matter is. It's anything that we can feel that is there. We can consider that to be matter, and there's obviously a lot of different properties that we have to classify these different types of things. So to introduce us to this section, they always kind of start off with a little example. So the example they give us here states that each piece of your clothing has a label that recommends cleaning methods. A 100% cotton shirt made to be ironed after washing. A cotton and polyester blend fabric may come out of the dryer wrinkle-free. There is no cleaning process that works for all materials. And so this is going to kind of play into the fact that your different clothing, again, are made up of different types of materials, therefore they have different properties, so therefore we're not going to treat them all the same. So that's going to kind of play into the fact that in our natural world here, there is a lot of different, better way to put it, a lot of different stuff out there that has a lot of different properties that we're going to have to look at. And the first piece of matter that we're going to look at are things that are called pure substances. And within pure substances, we have something that are called elements right here, and compounds. So those are our first pure substances, and we're going to dive into the fact of why we can call them a pure substance. So to start here, definition, I would definitely write this down, is that a pure substance is matter that always has exactly the same composition. So it is something that takes up space, that when we look at it, it's exactly the same all the way through. So our examples that they give us are table salt and table sugar are both examples of pure substances. So if we sent table salt and table sugar into a lab to have them analyzed, they're going to have the exact same composition all the way through. So that's what it means to be a pure substance. It's a piece of matter that always has the exact same composition. There's no discrepancies between two samples that fall within the same lot. They're all the same. And within our pure substance category, so that's kind of our big heading, but we have two kind of categories that fall underneath of our pure substance. We have something that's called an element and something that is called a compound. And we'll get into those here in a second. Oh, okay, so this is just another definition of a pure substance here. So every sample of a given substance has the same properties because the substance has a fixed, uniform composition. So this is just another way, again, to help us define what a pure substance is. Okay, so now we have our two different types of pure substances. So our first one is an element. So an element is a substance that cannot be broken down into simpler substances. So it is basically the bottom, as simple as you can get, the purest you can get is an element. So it is something that once we have an element, we cannot break it down any farther. And it has a fixed composition because it contains only one type of atom, and hopefully we know that atoms are just the little tiniest structures basically that we can study, and no two elements contain the same type of atom. So our first, smallest, kind of most simplest, kind of at the base of everything are elements, and because they cannot be broken down, again, they are pure, they're exactly the same composition all the way through. Again, you cannot be broken down any smaller than an element actually is. So some examples that we have at element, so some are actually solids at room temperature. An example is aluminum, because hopefully maybe you know that your soda cans that you drink out of, they're made out of aluminum. Again, that is an element. They're the same all the way through. And carbon is actually one of the main elements in the marks you make with a pencil. So those are two examples of solids at room temperature. Other ones that are now gases, so something again at room temperature that is a gas, is oxygen and nitrogen. Those are the two main gases in our air that we breathe every single day. So those two elements, again, very pure. Again, you can't break an oxygen or nitrogen down any farther. And again, they're in the gases that we breathe. And then two elements that are actually liquids at room temperature are bromine and mercury. So not every single element is exactly the same. Again, we have 6 examples here. Again, some are solid at room temperature, some are gas at room temperature, and some are actually liquid at room temperature. So that's I would maybe, for your quiz, I would maybe jot down one of each, maybe like one thing that's solid, one thing that might be a gas, and one thing that might be a liquid at room temperature. But this just is kind of giving us an indication that there's going to be a lot of different properties just within our natural world of different types of elements. Again, there are no real one defining answer that helps separate them all. There's going to be a lot of different properties, and because there are so many different ones, chemists actually use symbols of 1 or 2 letters to represent the elements. The first letter is always capitalized, and if there is a second letter, it is not capitalized. So that's the rules for whenever we are identifying our elements. Again, we don't always write out the entire word. We just have symbols, and again, the first letter always capitalized, second letter is not capitalized. So some of these, when we get to the rules, it's really simple. So C represents carbon, pretty simple. Al will represent aluminum. Again, that's pretty simple as well. However, there is it gets a little bit confusing because sometimes the Latin language gets brought in because we have the letters Au to represent gold. So the Latin name for gold is aurum, so that's where that comes from. So if you see, again, maybe letters that don't necessarily make sense as why would that stand for that, it's most likely because it is based off of the Latin name, because if you look in the back of my room, there's that periodic table, and there obviously isn't just 26 different ones that all start with different letters on that list. So that's why we have to get the Latin names thrown in there. And the reasons why we use these symbols is it's kind of similar to the reason why we use SI units, because it allows scientists who speak different languages to communicate without confusion. Because our example is nitrogen, is azote in France, if I'm pronouncing that correct, Stickstoff in Germany, and Nitrogeno in Mexico. However, all scientists across the world use N as the symbol for the element nitrogen. Again, it keeps it uniform, it keeps it the same across the board. Again, so we can kind of repeat each other's experiments, or we all know what we're talking about, again, at different parts of the world. So that's why we use the symbols, because it can allow us to speak and communicate much more easily. And then a couple more examples of just some uses. Again, aluminum, carbon, and gold are elements that you see in common objects such as cans, pencils, and rings. And mixtures containing iodine are used to prevent and treat infections. So we, again, down here at the bottom, just all examples of some different types of elements. And again, we use them more readily than what you might imagine. And our next... Okay, yep. So then our next pure substance, to kind of wrap this up, we're going to talk about is a compound, and is a substance that is made from 2 or more simpler substances and can therefore be broken down into those simpler substances. And a compound always contains 2 or more elements joined in a fixed proportion. So what that means is a compound can be broken down farther. However, when we look at a compound, it will always have the same arrangement of elements inside of it. So there's not going to be a bunch of crazy different confinements of different elements attached to one another. They're always going to be the same throughout the entire compound. And the properties of a compound differ from those of substances from which it is made. So our example is that water is composed of the elements hydrogen and oxygen, so H2O. So oxygen and hydrogen are both gases at room temperature. However, but water is liquid, so that goes up here to this fact that properties of a compound, they're different from the substances from which they're made, because 2 things that are gas at room temperature come together to form a liquid at room temperature. And then our next example here is that hydrogen can fuel a fire and oxygen can keep a fire burning. However, water does not burn or help other substances to burn. So again, on their own, hydrogen and oxygen are actually both very flammable. You put them together, they form water, and voila, they are actually the opposite of flammable. So that just says, again, we can put 2 or more elements together and their properties will change when they actually form their compound. And to wrap it up here, another example, silicon dioxide is a compound found found in most light-colored grains of sand and in crystals of quartz. It is a colorless, transparent solid. Yet silicon dioxide is made from a colorless gas, oxygen, and a gray solid silicon. In silicon dioxide, there are always 2 oxygen atoms for each silicon atom. So again, it just shows that we have 2 things that are usually colorless or gray, and they come together and they can form crystals that are all different types of colors. So that is just another example, again, based off the fact that the properties will differ when we bring them together. So that's it for the first part of Section 1. Let me know if you have any questions.